For learning objective B, we're going to see how we can test if an imaginary or complex number is a solution to a certain equation. We're going to do 3 different examples. This one says we have the equation x squared plus 9 equals 0. They want to know if x equals 3i. So I can take 3i and put it in for x. If I do that, it's 3i all squared plus 9. Now I'm going to test it out and see if I simplify when I do it, if it equals 0. Remember 3i squared is 3i times 3i. 3i times 3i would be 9i squared, and then plus 9. I squared is negative 1 plus 9. 9 times negative 1 is negative 9 plus 9. When you simplify, you get 0, which is what they said here. So I would circle yes, it is an answer. Let's take a look at number 2 here. We have the equation 2x squared plus 14 equals 0. Is I times the square root of 7 an answer? Let's put it in for x. Now be cautious here. This 2 is just sitting out there. The only thing I'm squaring is this x, so I'm going to put this in here and then do plus 14. And I'm going to do the math to see if it comes back to 0. I'm just going to repeat this twice like it says. So I square root of 7, I square root of 7, and then a plus of 14. I times I is I squared. The square root of 7 and square root of 7 can be crunched together. It's 7 times 7 is going to be 49. So I'm going to call this the square root of 49. This number 2 is still sitting out there. And don't forget plus 14. Well, the square root of 49 is the number 7, so really it's what's 2 times 7, then the I squared plus 14. 2 times 7 is 14. I squared is negative 1 plus 14. This does negative 14 plus 14 equals 0. So yes, this one is also a solution. The last one we're going to look at is a little lengthier, but very doable. We have the equation x squared minus 2x plus 1 equals 0. Is the complex number 1 plus I an answer? Now be careful, x shows up twice. You need to put it here, and you have to put it here. So when I put it in, I have to square it, so 1 plus I all squared. Then minus 2 times 1 plus I, then plus 1, and I'm going to see if that equals 0. Don't forget my squared up there. Now be careful, don't distribute that little 2. You have to repeat the base twice. So I have to repeat 1 plus I 2 times. Come back to that. I'm going to take this negative 2 and distribute it through. So negative 2 times 1 is negative 2. Negative 2 times a positive I is negative 2I, and then plus 1. I'm now going to FOIL this. 1 times 1 is 1. 1 times a positive I is plus 1I. And I times a positive 1 is plus 1I. And I times an I is plus I squared. As I look at this latter half here, I'm going to combine these two real numbers here. So negative 2 plus 1, because they own the sign in front of them, is negative 1. And then I have the minus 2i still there. Now I'm going to simplify. I'm going to keep the 1 here, this blue 1. I'm going to do 1i and 1i is 2i. And I'm going to change the I squared to negative 1. Then I'm going to keep the minus 1 minus 2i just for a second. If I add the numbers together, I notice that 1 minus 1 is 0. That goes away. I notice 2i minus 2i is 0. That goes away. But keep in mind, I never use this particular number here, so this is going to equal negative 1. Unfortunately, this equation says it should equal 0. Because of that, I know that 1 plus I cannot be a solution to this particular quadratic equation, so I would say no.